humanity has existed for countless generations and pondered a profound question. Are we truly alone in the vastness of the universe? Despite the fact that it has remained unanswered for centuries, the rise of artificial intelligence may finally offer a breakthrough. Recently, Google's artificial intelligence discovered strange transmissions from deep space signals so refined and distinct in their apparent alignment with almost every standard that scientists have established for potential communication with extraterrestrials. Amazingly, these signals had vanished, hidden for years in the middle of massive streams of data, until AI analyzed them with care and brought them to light. Could this be the definitive confirmation of our anticipation? The revolutionary discovery involved 8 separate radio transmissions, all of which raised eyebrows throughout 2023. These were not, as the scientific community initially thought, mere sporadic space noise. They were pinpoint narrow-frequency signals that were only visible when astronomers used telescopes to focus on particular celestial bodies, disappearing completely as soon as those telescopes swung away. What further enhanced the finding was how these transmissions had previously slipped through the cracks. Despite countless hours of human analysis, it took an AI system digging into a massive 150 terabytes of data gathered by the Breakthrough Listen project, an immense determination to finally locate them. For perspective, that's equivalent to analyzing more than 30,000 high-definition movies. These enigmatic indicators checked every essential box typically used by scientists at SET to identify potential alien transmissions. First, they exhibited directional consistency, merely surfacing when instruments were focused on designated star systems and vanishing otherwise. This is a pattern pointing to an extraterrestrial source. Second, it displayed an extremely limited frequency range, typically just a few hertz wide. This level of precision is rarely delivered by most astronomical sources like pulsars or stars, which send out signals over a third larger range. Third, they displayed a slight shift in frequency over time known as Doppler drift, which suggests the source is probably moving, turning or circling in a manner similar to what we'd expect from a planet-based transmitter. Intriguingly, the system responsible for this remarkable detection wasn't developed by a leading scientist, but by Peter Ma, a University of Toronto student. He created a learning algorithm based on Google's TensorFlow neural network. His AI was able to pick up what traditional data sifting methods had completely overlooked in AI that was later used to reevaluate years of astronomical records. Many believed to have already been thoroughly investigated. Scientists were shocked by what they found: previously undetected signals in a 2017 dataset involving researchers examining 820 nearby stars. The Breakthrough Listen project, which takes the initiative in the search for intelligent extraterrestrial life, adopted this AI system to reclassify signals once discarded as irrelevant noise. This represents a significant shift in extraterrestrial intelligence research. In the past, the search for life beyond Earth was constrained by human-developed algorithms and detection methods that may have unintentionally ignored crucial clues due to their rigidity. By turning over the reins to artificial intelligence, researchers are now finding new pathways forward. AI doesn't just examine the data faster, it interprets it in entirely novel ways, revealing clues the human mind would never have discovered. The role that AI plays in SETI has revolutionized the process of examining the heavens. Before attempting to detect extraterrestrial transmissions was similar to looking for a grain of sand on a never-ending cosmic beach. The obstacle? We didn't even know what the grain looked like. AI has drastically redefined this hunt. Scientists now employ robust machine learning systems to sift through millions of gigabytes of radio data, seeking out even the faintest anomalies that may indicate a deliberate origin. These algorithms focus on more than just speed. Unlike older systems that rely on predefined fixed signatures, AI can recognize subtle differences and unidentified connections in the data. It can distinguish genuine deep space signals from earthbound interference, such as emissions from cell phones, radar, or satellites, something never achieved before. The SETI Institute has now integrated these AI systems into their radio telescopes, allowing real-time signal evaluation at a scale that was once science fiction. Observational data now flows continuously through neural networks that adapt to each new set of information, improving their capacity to spot potential signs of intelligence. As astronomer Cherry Ng, a graduate who contributed to the creation of the AI that uncovered those 8 signals, claims, "This technology doesn't say we found aliens. It helps scientists assess such phenomena more methodically." Although attempts to redetect the same signals have so far failed, a crucial step in confirming authenticity. The fact that AI flagged them at all shows how this technology may change the world forever. Moreover, AI's contribution isn't limited to flagging strange signals. It's also fostering entirely new conceptual frameworks for imagining alien technology. Rather than relying solely on human reasoning, machine learning allows the identification of patterns that may be completely foreign to current human speculation. As an analogy, finding a piece of the cosmic puzzle remains apt, but the haystack we're searching in now spans across the universe. Asterisk. The observable universe and a needle might belong to humans. We wouldn't even recognize it if we saw it. This is where our eye's objective lens becomes invaluable. CTI teams now make use of cutting-edge machine learning systems influenced by technologies from industry leaders like Google and NVIDIA. These models don't just replicate human pattern recognition, they surpass it. Conventional algorithms are bound by templates created by humans. But AI excels at discovering anomalies and patterns that defy convention. This is essential, considering that any extraterrestrial technologies could be used by civilizations far beyond our comprehension. AI filters through torrents of earthly interference like military radar, satellite chatter, or radio waves, in order to locate the rare signal that might genuinely originate from the stars. These systems are constantly learning. Every new piece of data enhances their understanding of what consists of typical cosmic events versus what could be extraordinary. The scale of their computational reach is mind-boggling. Today's AI-powered SETI systems analyze more data in 24 hours than traditional searches did across multiple decades. As quantum computing matures, these already powerful capabilities are expected to grow exponentially. Possibly the most important quality that AI adds to this pursuit is its lack of bias. Human scientists naturally focus on signals that mirror our own communications, such as narrowband radio emissions or structured light pulses. AI is not restricted by these expectations. It detects anything that statistically stands out from the backdrop, even if it resembles nothing familiar. This flexibility is likely our best bet at identifying thousands of civilizations, millions of years ahead of us. Beyond the stars, the field of SETI AI is propelling many space research advances. In 2017, for instance, Google's AI made headlines after helping NASA identify Kepler 9.0i, a planet orbiting a distant sun, making that solar system match our own in planet count. Remarkably, this world had been previously missed by astronomers. Chris Shalyu, a Google AI researcher, developed a neural network with engineer Andrew Vanderberg. It was trained to detect minuscule dips in luminosity when planets cross their stars, signals far too subtle for earlier systems to catch reliably. This success inspired another collaboration in 2019 between Google and the University of Texas at Austin, which led to the discovery of 2 more previously unknown buried exoplanets. In Kepler's later mission data, the AI had found them hiding in plain sight. Perhaps the most dramatic example, Google's TensorFlow framework was applied in 2018 to reveal 72 previously undetected fast radio bursts (FRBs) from a repeating signal source that was initially known as FRB 121102. Scientists had only spotted 21 such bursts from that object. The AI tripled this figure, transforming it into the most complete FRB source ever compiled. These accomplishments demonstrate how AI is not just complementing research, it's taking the lead by discerning patterns invisible to human perception. AI cross-references data across vast multidimensional arrays, setting new standards in observational science. Instruments like the James Webb Space Telescope arguably humanity's most advanced space observatory, now rely on machine learning to isolate significant signals from enormous datasets. Everything from pinpointing faint galaxies to interpreting atmospheric signatures of exoplanets now requires AI. This dynamic partnership between machine cognition and human intuition is opening brand new cosmic ENTRYWAYS comprehending each data cycle adds value, further enabling these neural systems to become more adept at distinguishing between noise and potential insight. While the 8 signals flagged in 2023 certainly drew worldwide attention, even more powerful AI tools have since taken their place. In monitoring the heavens, in New Mexico, it's a very large array, one of Earth's premier radio telescopes has been augmented with a real-time AI system dubbed Sidecar, capable of analyzing a staggering 2 trillion pieces of data every single second. This system continues to acquire real-time adaptive knowledge to look for deviations that might indicate the presence of intelligent life, proving once again that in the age of artificial intelligence, the question of whether we are alone may finally have a chance at being answered. With each new observation, Sidecar hones its capacity to detect the faintest of anomalies. The idea is no longer just to look for familiar signals or patterns that are repeated, but to identify the unknown, those rare, one-time bursts or modulations that defy classification by conventional means. Sidecar runs continuously, ensuring that no moment of potential significance goes undetected. What used to require months of post-processing by teams of scientists can now happen in seconds, allowing near-instantaneous identification of targets worth deeper study. As AI integration progresses, the procedure of gathering data and the flow of analysis are becoming more interconnected. Currently, systems are being built that not only detect and classify anomalies, but also independently trigger observational follow-ups using other instruments. For instance, if one AI observatory notices something unusual, it can immediately alert another facility, whether across the globe or in orbit, to direct its sensors to the same coordinates. This synchronized, multi-wavelength response in real time, something impossible just a few years ago, is revolutionizing the pace and depth of astronomical research. But perhaps the most profound shift that AI is causing is not limited to our technology. To our philosophy, the search for extraterrestrial intelligence is no longer guided purely by human curiosity and perspective. Instead, it is now a collaborative endeavor.